So as I have written in the title of this video, this is a question from JEE 2026 that is technically from complex number. But even if you have not studied that chapter, please do not skip this video because I'll be teaching you something about it that requires almost no other knowledge other than some basics of theory of equation. If you know complex numbers but were still not able to solve this question, you can skip the starting of this video where I will be explaining the theory pertaining to this question, which is of cube roots of unity. So the first part of the video is for those students who have not studied complex number but who still can solve this question based on a study of just a single topic. So the question here is if alpha and beta are distinct roots of the equation x square plus x plus 1, and we have these two questions, and then we have another two questions based on two different equations. It looks lengthy, but the basics of all the questions are almost the same. So let us start with the theory part first. Cube roots of unity are basically those numbers that when raised to the power 3 give 1. Basically, let us assume any variable x that raised to the power 3 will give us 1. This equation has three roots, one of which is real and the other two are complex numbers. The three complex numbers, because every real number is also a complex number, so the three complex numbers that satisfy the above equation, or what does it mean when we say a quantity satisfies an equation? It means that it is the root of the above equation, are called cube roots of unity. So basically, when you factorize this, it is very easy. X cube minus 1 comes this side, and then you have a cube minus b cube formula, which gives us x square minus 1 x square plus x plus 1 is equal to 1. Now from this you can easily get x is equal to 1. That is not the tough part, or that is not the new part. The new part is when we factorize this using quadratic formula. So when you apply quadratic formula to this, you will easily see that b square minus 4ac comes out as, in the under root you will have 1 minus 4. This comes out as minus 3. So if you have not studied complex number, you will not be able to understand how to treat this. But this is very easy. What we do in complex numbers is we write this minus 3 as under root of 3 into minus 1. This can be done, as I told you in the last video, this can be done when either of these two factors has to be positive. So both cannot be negative. It cannot be both minus 3 into minus 1. It can be 3 into 1. It can be 3 into minus 1. It can be minus 3 into 1. When that happens, then you can do it this way. Then you can write this as under root of 3 into under root of minus 1. This is under root of minus 1 is something we take as I. So it just becomes plus minus root 3i. So the three roots are x is equal to 1 and x is equal to minus 1 plus minus under root of 3 iota by 2. I is just a number we use. This is what complex number is, right? I is used to denote under root of minus 1. Now we assume that let omega is minus 1 plus under root 3 of I. That is, let us assume that one of the roots is, when we take the positive sign of this, minus 1 plus under root I upon 2. So you can call it any variable, but the standard notation is to call it omega. So let omega be minus 1 plus under root 3i by 2. Let it be the first root. Now interestingly, when you square this root, omega square, you observe that it becomes the second root, minus 1 minus root 3i by 2. When you square this, you will observe that this is the second root. So omega and omega square, which are the roots of the equation, are nothing but squares of each other. So if you would have taken omega, this as omega square minus 1 plus under root I by 2, you can do that. Even then omega would have come at minus 1 minus under root of I by 2. So it doesn't matter if you take this as whichever value you take this, the other root will always be the square of that, which is why the cube roots of unity are 1, omega and omega square, and these two will always be squares of each other. It doesn't matter what you take as omega, which root you take as omega, it will always be the square of the other one. That's just a symmetry which is inherent because of the way these values are. Now the interesting thing is omega raised to the power n when n belongs to any natural number. Let's say n is 1, 2, 3, 5,600, anything, it can be any natural number. Omega satisfies x cube is equal to 1. Therefore, omega cube will be 1. So, omega raised to the power 3k will be always equal to 1. Similarly, when you raised omega raised to the power 3k plus 1, you can simplify as omega raised to the power 3k into omega. And this quantity is always 1. Because again, right, What is omega? Omega is basically the value which satisfies this original equation. X cube is equal to 1. Therefore, omega cube will always be equal to 1. So whenever you have omega raised to power 3k plus 1, you can simplify. Again, this is exponents, right? A raised to the power b plus c is a raised to the power b into a raised to the power c. So in this way, omega raised to the power 3k plus 1 will always come as omega, and omega raised to the power 3k plus 2 will always come as omega square. Again, this is simple exponents. So let us get to the question. The roots of this equation x square plus x plus 1 is equal to 0 are given as alpha and beta in the question. Right, and why was I talking about complex numbers and omega throughout? Because it becomes very easy to solve this question formulated that way, right? That when you know about cube roots of unity, this quantity will not look as tough as it is, because the manipulations becomes easy when you know about the properties of the roots of this equation, as you will see, and all the properties now I have told you. So basically what they have done is they have said that instead of omega and omega square, they have called this alpha and beta, and now we know the properties of alpha and beta, because alpha and beta are nothing but omega and omega square. That will make the manipulation of these quantities very easy. So again, this is a very overwhelming page, but stay with it from the top, one line at a time. Let us call alpha as omega and beta and omega square. As I said, it doesn't matter. You can call alpha as omega square and beta as omega as well. The value we need is 1 upon 1 alpha plus 1 raised to the power 2026 and 1 upon beta plus 1 raised to the power 2026. So let us focus on this first. Let us focus on the denominator first, and then we will take its reciprocal. So alpha plus 1 raised to the power 2026 is nothing but 1 plus omega raised to the power 2026. And omega satisfies this original equation. So when you substitute omega here, omega square plus omega plus 1 will be 0. So from here we will get the value of 1 plus omega minus omega square. We just put it in this equation, in this value, in this term, we just put it here. So what we will get is minus omega square raised to the power 2026. Then again, it's basic simple exponents. How you simplify it, it will become omega raised to the power 4052, which is nothing but omega raised to the power 3k plus 2. K can be the value which divides 4050, because this is of the form of 3k, right? How we manipulated exponents here in this one, it is basically the same. So we will get omega raised to the power 3k plus 2 is nothing but omega square from here. Similarly, beta plus 1 raised to the power 2026 can be obtained by 1 plus omega square, because beta is omega square, and again it will satisfy this equation. So 1 plus omega square is minus omega. So it will be minus omega raised to the power 2026. Again, it will be of the form omega raised to the power 3k plus 1, because this value 2025, this is divisible by 3. So this is of the form of 3k. And so we have only one value, only one left after this. The remainder divided by 3, when we divide 2025 by 2026 by 3, with the remainder will be 1. So this is basically of the form of omega into 3k plus 1, which is nothing but omega from here. So finally, what we want in the original question is 1 upon 1 plus omega raised to the power 2026, 1 upon 1 plus beta raised to the power 2026. When it goes to the denominator, it becomes 1 upon omega square. Similarly, this becomes 1 upon omega. Now again, it's simple manipulation. Now this question becomes easy precisely because of this, because this manipulation we already know. 1 upon omega square, we can write it as 1 into omega, omega square into omega. Basically, numerator and denominator we are multiplying by the same quantity. So this becomes omega upon omega cube, and we know that omega cube is always equal to 1, because this satisfies x square plus x cube is equal to 1. This will be nothing but omega. Similarly, this will not be nothing but omega square. So this value is nothing but omega and omega square, or if we would have taken other roots, omega square and omega. So finally, we have found the value of these two terms, and what we want is a quadratic equation whose roots are these two terms. So again, we have an equation whose roots are omega and omega square, and omega square are the roots of this equation. So finally, the quadratic equation with this roots will be this one again. This is the first answer. Similarly, we can solve this one, that is precisely exactly the same way in which we have solved the first part from here. It is precisely the same way. Instead of 2026, the exponent will be 2027, and then you can easily solve it. I am leaving it as an exercise for you so that you can know if you've understood what omega and omega square is and what the cube roots of unity are and how you can manipulate it. So this option I'm leaving for you. Now let us move to this one. X square minus x plus 1 is equal to 0 and gamma and delta are the roots. Now interestingly, let us take a look at this equation. Gamma and delta roots are, again by applying quadratic formula, 1 plus minus under root of 3i by 2. Now if you'll notice, this is nothing but, let us take the minus sign common outside. Okay, so this will be minus 1 minus plus, because we have taken the minus sign outside, root 3i by 2. So again, what we have, roots are nothing but minus omega and minus omega square, or you can write it as minus omega square and minus omega, it doesn't matter, these are symmetrical values. So gamma is nothing but, let us take gamma as minus omega and delta as minus omega square. You can proceed it in opposite way also. You can take this as minus omega square, you can take this as minus omega. It's symmetrical. So what we want here, similar to the previous thing, this whole term is in the denominator. So let us focus on it first. Gamma minus 1 raised to the power 2026, which is nothing but minus omega minus 1 raised to the power 2026. Minus omega satisfies this equation. So just put it here. Manipulate it. You will get 1 plus gamma in raised to the power 2026. Manipulate this equation, that will be minus omega square from this equation into raised to the power 2026. Again, similar to the previous time, we have already done this. The value is omega square. Very similar manipulation in this one, exactly similar. The value would be omega. So the whole value that we had to find in that option is nothing but, when this goes to the denominator, this also goes to the denominator, and we add a plus sign, it will nothing be 1 upon omega square plus 1 upon omega. Again, multiply this by omega omega, this by omega square, similar to how we did it here, and the values would be omega and omega square. Now we know 1 plus omega square is 0, because omega and omega square are the roots of x square plus x plus 1. So omega plus omega square will be nothing but minus 1. Now as I said, this question would have been a bit lengthy, I guess, or a lot lengthy, if you had not known about the properties of omega and omega square. Which properties? First of all, that they are squares of each other, and the other, that when you manipulate it, the higher exponents, they are simplified in the form of omega raised to the power 3k, omega raised to the power 3k plus 1, and omega raised to the power 3k plus 2. Technically, this is a question of complex numbers, but if you, even if you had not studied that chapter, if you have understood the theory, I explained it here, that this is just one part of the complex number chapter. This is just one heading, right? You will learn it when you read complex numbers, if you have, they have not taught you in your coaching yet, but I've already taught you here, right? So when you will be when you will be taught this in your coaching, you will already know what it means. So finally we move to this last option, and I don't think this will require any knowledge of complex numbers. P and R are distinct roots of x square plus x minus 1 is equal to 0. So we have to find this value. So for that, let us focus on the equation that P and R are the roots of x square plus x minus 1 is equal to 0. Let us take 1 to this side. 1 will be here. We will factorize this. It will be x into x plus 1. So 1 upon 1 plus x is equal to x. P and R are roots of the equation, so they will satisfy this. So 1 upon 1 plus p will be equal to p. Similarly, 1 upon 1 plus r will be equal to r. So when you will cube both the sides and add them, you will get 1 upon 1 plus p whole cube, 1 upon 1 plus r whole cube, p cube plus r cube. Now again, this is basically a cube plus b cube, which is a plus b whole cube minus 3ab into a plus b. We all now, this is basically simple theory of equations. This is what sum of roots, minus b by a minus 1. This is product of roots, c by a, again minus 1. Substitute the value, you get the answer minus 4. So as I have said repeatedly, the goal of this channel is to simplify JEE in a way, even if you think that you have missed some part of theory of some chapter, even then you can solve a lot many JEE questions than you think that you can solve. Obviously, studying the theory is very, very important. But sometimes in exams, what happens is, let's say in your unit test, you might not have been, you have backlogs, right? You might not have been able to study one chapter to the extent that you might have wanted to. But even then, you can solve many more questions if you apply simple logic. Follow this page to understand more on the problem solving part of it and how to approach questions when it comes to JEE Maths. Theory is something that will, you can study from any book, that you can study from any coaching classes. But how to approach questions is what I will be teaching you on this page. So please don't forget to follow, and please don't forget to check out the other questions uploaded on this page. Thank you.